So welcome back to our webinar or training actually. Now let's talk about roles and players. Roles and players are examples from the M2M ecosystem. Okay, those are market or main market players for remote SIM provisioning. So currently GSMA is announcing so more than 90 players, majority industry players supporting the initiative. I have two more players involved, especially in the consumer world as well. So it's currently, as you can see, for example, Apple and Google inside, they are not GSMA members, but they're also involved in technology. The USSC manufacturers, so these are the examples of the USSC manufacturers. So as it mentions, there are more than this. You can see, yes, former Gemalto, now Thales, G&D, IDEMIA, Valid ST, so defining the technology. And actually, yes, NXP, Infineon acting as, the USC manufacturers as well. The SMDP, Subscription Manager for Data Preparations, this entity is usually owned by the operator because the operator, it depends, it's a question of trust. So because there is this, the profile will be delivered to the SMDP, even though there are security assessment schemes to certify the SMDP, but still, so the big operators have their own SMDP. Yes, and we have different providers. So, for example, ARM, yes, and also ARM, Ericsson, Truthphone, and former EUSSC manufacturer or USSC manufacturers, they started to act also on the other side. So they don't, they are not only producing the EUSSC itself, but also have the second part of the communication, the subscription manager for this. Yes, and here we have Gemalto, now Thales, and GD. Yes, for the subscription manager secure routing, so this entity usually belongs to the service provider. Yes, examples, so General Motors or Volkswagen, also in the automotive area, so they have their own systems. And yes, actually this is the entity, so it's different. So who provides, who produces the system, and who is using the system. So in the real world, so in the real world, service provider, and so who is producing this? Yes, actually basically the same players additionally. So some players are acting only in the role as a secure routing entity, but not as a SMDP, because sometimes it's so you can separate. You don't have to have the full system in your own house. So yes, and here we have, for example, the HPE or Hewlett-Packard Enterprise acting in the secure router operator. Yes. So we have a big part on the left-hand side here. So many of them involved in this technology and monitoring or acting in different areas. The certificate issuer. GSMA has selected PKI providers, so public key infrastructure providers, to act on its behalf as a root certificate issuer. So actually this is GSMA who is acting as having a role of the certificate issuer, but they have their companies, the partners. So for M2M, it's Cyber Trust, and you can find it on this pages. So you will have the links. And you can download the root certificate. So this is the link here to download. And you can download, so you can go to the website and connect to them by using email. So this was a short summary about the roles and players on the market. Now the market is growing. So we had this first part was with the different deployments. So they have different roles inside of this ecosystem. So we had in this slides, we had the manufacturers, but the companies who are using the service providers, for example, or deploying using the EUSSC in the ecosystem. So there are way more. Okay, take a deep breath. We go to the security aspects. the keys, certificates, and algorithms. Okay, the GSMA is defining the specific PKI, or public key infrastructure. Yes, there is a root CI, or root certificate authority, so this is everything is controlled by documents, or defined in the documents actually. So not just doing what they want to do. And so there is a GSMA policy authority responsible for this, and there are documents for this. And yes, so you can see, so we have the 2 levels hierarchy. So the first of all, so the GSMA, so CI, or root CA, so is yes, issuing certificates to the sub-CA. So the sub-CAs in this case, so in the M2M world, it's the EUM only. So it's sub-CA. So sub-CA, we're talking about sub-CA because the EUM issues another certificate to the EUSSC, which is and then we have kind of a chain. And this EUSSC certificate can be verified using the EUM certificate, but the EUM certificate can be verified using this root certificate. For the other components, the SMDP and the SMSR, all of the operative functions or certificates, they are issued directly by the GSMA CI. And you can see, so this is the technology level, so and this is kind of governance level, so with the policies. So the GSMA defines the policy, and the PKI comprises a 2-tier and infrastructure with an offline root certification authority as a tier 1, the EUSSC manufacturer as a tier 2 sub-CA. So root CA issues the EUM certificates and end entity certificates for servers. SMDP, SMSR, SMDP Plus, and SMDS. Okay, so this is now not relevant for M2M, so for SMDP Plus and SMDS, but this is in general. The EUM sub-CA issue the end entity certificates for the EUSSC. The certificate policy for the GSMA PKI is consistent with the Internet X509 PKI certificate policy. You probably know this from the regular Windows certificates. And certification practices framework. The certificate policy governs the operations of the PKI components by all individuals and entities within the infrastructure. It provides the requirements that PKI participants are required to meet when issuing and managing certification authorities, certificates, and private keys. And additionally, it informs potential relying parties about what they need to know prior to relying on issued certificates. So the certificate policy describes the overall business, legal, and technical infrastructure of the GSMA PKI. Let's take a look on the hierarchy. So more deeper, and also take a look on the names. First of all, the trusting or root of trust, the GSMA root certificate. So it's called cert.ci ECDSA. So ECDSA, so as you know this cryptographic protocol, and so you can see that this is the DSA on the elliptic curves. And actually, in all of the GSMA EUSSC ecosystems, the elliptic curves are used. GSMA issues the self-signed the CI certificate, acting as a root of trust, and so the public keys contained inside of the CI certificate, and the private keys so is kept in secure part from the GSMA CI, and private key is used to to issue certificates of the sub-entities. Okay, now you can see the chain. Yes, the EUM certificate is called cert EUM ECDSA, and again, the public key is inside of the certificate, and the private key is as key EUM ECDSA is kept in the secure part of the EUM infrastructure. This private key is used to sign the EUSSC certificate. The EUSSC certificate is now called the ECSD. So you remember the issuer, the EUSSC controlling authority security domain. So we are still in the elliptic curves world, but so the Actually, so in the middle, so it should be EUSSC, but since they're cryptographically inside of the EUSSC, this is the authority, so responsible inside of the EUSSC, the security domain, keeping in charge of all of the certificate and cryptographic operations. Yes, therefore it's called ECSD, but the ECKA is the crypto key agreement on the elliptic curves. Therefore, the second part describes the algorithm. The GSMA CI signs or issues the SMSR certificate and the SNDP certificate. So now you can see already from this hierarchy, so that so the entity, or the certificate of the entity and public key of the entity which is issuing this particular certificate can be used to verify the correctness of the SMSR, or yes, the correctness of the entity. So in this case, it means if we have the EUSSC, then EUSSC can use the root of trust, the root certificate, to verify if the SMDP or SMSR certificate is authentic. And other way around, so the EUSSC, so the SMDP or SMSR uses the EUM certificate to verify the authentic, to authenticate the EUSSC, the correctness of the certificate of the EUSSC. Yes, and the EUM certificate can be verified by the GSMA CI root of trust. Just a few words to the format. The format of the GSMA CI certificate and the EUM certificate, so of the sub-CAs, is the X509 classic format of the certificates. The format of the SMSR, SMDP, and EUSSC certificates is more known in the smart card world, so it's called now GP format, actually based on ISO. Yes, so the format is a different one, so it will probably not be read by a regular tool to read the certificates or displayed properly, parsed. Meaning for the security settings, the EUSSC has the following settings. So sometimes you can have some issues inside of your system, so because something from the security side is not working. This might be the reason, the reason for this might be that the certificates are not correct, or you have another trust anchor inside of one of the components. Okay, the EUSSC contains the CI public key, so actually the certificate. So the trust anchor inside as a trust anchor to verify the validity of the SNDP and SMSR certificates. So if there's this trust anchor inside of the EUSSC is a different one than those which was used to issue the SNDP and the SMSR certificates, then you will get an error. Okay, for sure, the EUSSC has its own private key. It's used for the EUSSC authentication and the key establishment. Yes, since we have the key agreement, so you know the private keys is always used. So private key of one entity and public key of another entity. And yes, the certificate for EUSSC authentication and key establishment is actually the EUSSC certificate corresponding to the secret to S key, private key of the EUSSC. This certificate is part of the EUSSC information set. You remember, this information set will be stored on the SMSR, on the EUM level, and on EUM level. Yes, so actually the EUM knows the certificate and then it delivers this as the SMSR. Yes, and it's verified by the public key of the EUM certificate. Okay, this was the EUSSC part. So the settings for the operator communication. So they need the OTA keys. For example, so the MNO CP80 encryption key. So for the initialized as default MNO SD key ID1 and the SCP80 authentication key. Yes, sometimes SCP81 is used, so then optional can be, those keys can be included as well. The platform settings for SMDP and SMSR configuration. Okay, again, the trust anchor has to be there in the system inside of the SMDP and the SMSR. CI public key, has to be included and is used to verify the validity of the EUM certificate and subsequently of the EUSC certificate. SMDP certificate for SMDP authentication and key establishment. So this key is used for the profile download, and used for the authentication of the SMDP. Yes, certificate as ZSR is CDSA, so this SMSR certificate is used for SMSR authentication. Yes, and key establishment, but in the process of the SMSR change. Yes, and finally, so the EUM certificates. Okay, so this is a platform setting, so because normally, so the platforms also have this EUM certificates. Yes, certificate is issued to GSMA certified or accredited EUM. So we'll talk about the certification in the last part of the training. Not today, not in this part, so in the fourth part. Yes, and yes, only the accredited entities, accredited SMDP, SMSR, and EUM, so they will receive the certificates from the GSMA CI. Yes, and this certificate is used to verify UCC certificates. That's all for this security part on the basic level. So I think it's difficult to understand. So, but just to keep in mind, so we have this trusting inside of the UCC, and we have different set of keys. So this is important to to remember, because sometimes even when people are involved in this groups and the technology groups, so sometimes even those people mix it up. So because we have different set of keys, actually we have different types of keys. So meaning, okay, we have the classic network connection keys or network access keys, which are used to connect to the network, for example, using Millinage or TURC algorithms or whatever. But these are not mentioned or not part of the GSMA remote SIM provisioning process. Okay, then we have the regular keys, which are used by the MNOs to perform some operation on the EUSSC at the time when the profile is active. So when the profile inside of the EUSSC is enabled, then the EUSSC acts as a regular USSC SIM card, and then the operator can do some changes using the ES6 interface. For this purpose, so the operator uses its own keys, which are stored inside of the profile. Okay, this were what I mentioned also by SCP-80 keys, for example. MNO keys. Those keys are different. So for the remote application management, remote file management, all this OTA communication, different keys. And then we have actually our keys, what I was talking about here, mainly. These are the certificates and the keys which are used for actually the remote SIM provisioning itself. Okay, and all of the systems is based on the PKI infrastructure. Actually, then we have this first step of the verification of the validity of certificates and authentication. Actually, using this trust anchor, the public key, public certificate of the CI, the GSMA CI. It has to be pre-stored in the server entities and the USSC. And yes, then we have also the cryptographic protocols inside of it. So, and the keys are used to establish the communication channels, the secure channels. So the secure channels are based on elliptic curves. And I've mentioned this before already. So we have the SCP-80, SCP-81 on one level. And then we have for this other envelope SCP-03 or SCP-03T protocols to encrypt the data. And the keys, so actually, as you know, okay, the certificates and this authentication process, those are the asymmetric keys, the public key and private key always. And afterwards, you can use the key agreement algorithms to derive the specific keys, which are symmetric keys, and to be used for the encryption afterwards. So the SCP-03 and 03T are symmetric protocols, using symmetric protocols. And yes, afterwards the keys are agreed on both sides and then can be used to encrypt the data. Okay, This is for the cryptography. Now a test for if you paid attention, or you can go back in mind for this. How many certificates are used in the M2M architecture? So now it's easy to calculate. So the M2M scheme is, yes, at least from the components, is simpler than the consumer devices one, and especially as the consumer devices one in the future versions, upcoming versions. Yes, so I hope you can keep this in mind. Which certificates are necessary for the EOSCC? Okay, which certificates are needed for authentication of different entities? We had only 3 questions here. I hope you can somehow keep in mind how it works. This was the security part of the training, so for the basic part only. So I think this is enough to understand the basic concept of the security inside of the M2M ecosystem. The more detailed part, when we talk about the protocols and actually the single steps, how these protocols are working, so this will be part of the advanced training on the M2M. So I hope you will take a look on this as well. So after the basic training, so depends on your interests. Thank you very much for your attention. Have a good time taking another look through the slides, going through it once again. Please try to remember all of the names, otherwise you will be lost, and use the glossary inside of our presentation. Okay. Hope you see you again, or welcome you again. Enjoy it. Bye.